Okay, and now we're going to start to use different integration techniques to be able to do different things. In the past, you've basically used integration to find the area under a curve, but now we can do other things as well. For example, we can find the length of a curve. So here's a formula for it, and here's an example. So key thing with this formula is about the radius of curvature formula from differentiation. We've got to be able to work with the derivative of the function. So the first thing we have to be able to do is get dy by dx. So if we rearrange this equation to give us y equals x to the power of 3 over 2, and differentiate that, so dy by dx is 3 over 2 x to the power of 1/2 would be a really useful start. And then we can just bung this into our equation. So the distance of our curve is the integral from 0 to 4, square root of 1 plus our derivative, 3 over 2 x to the power of 1/2 squared dx. And which means we now have to do a little bit of mucking around, a little bit of algebra. So what have we got here? We've got the integral from 0 to 4, square root 1 plus, so that'll be 9 over 4 x square rooted dx. And for me anyway, I always find a square root when I'm trying to integrate things, unless it's got a formula that just looks like that, which I don't. It's a bit easier to deal with if I try and deal with it as a half power. And that's reasonably straightforward to integrate because it's just a half power. The derivative of this bit happens to be 9/4, and away we go. So if we integrate this thing here, we end up with that whole thing, to the power of 3 over 2, 2/3 of that to deal with the 3 over 2, and if we differentiate it back, we get 9 over 4, so we need 4/9. Or you could do that by a full substitution if you wanted to, but that inspection method works just fine. So sticking numbers in, so what have I got? I've got 8 over 27 out the front. I might as well take out the front of the whole thing. And then I've got the 4s will go out here, so I've got 1 and 2, 1 and 9 is 10, to the power of 3 over 2, 10 to the power of 3 is 1,000, so I've got the square root of 1,000. Minus, I mean 0 in there gives me 0, gives me 1. Okay? And personally I'd probably leave it like that, but if you stick into a calculator, it comes out to be 9.07. Okay, so the length of the curve of this function, so if we sketch this function, which is effectively just y equals 3, so it's somewhere between a line and a parabola, so it'll go something like that. If we did that between 0 and 4, okay, then the length here is going to be about 9.